Today we are starting Unit 9, which is exponential and logarithmic functions. And I think you guys will find this unit especially interesting because we actually have a real-world example of an exponential function, which is the coronavirus. So you'll probably remember from Algebra 1 learning about exponential functions, but we are going to dive deep into it for Algebra 2, and then we're going to actually learn something new called logarithms later on in this unit. So let's go ahead and review those concepts from Algebra 1. What is an exponential function? Well, it's a function that has its variable in the exponent. So here we have f of x equals b to the x. So an example of an exponential function would be like f of x equals 4 to the x, or f of x equals negative 3 to the x, anything where x is in the exponent. Something that's not an exponential function would be like f of x equals x squared, because here 2 is in the exponent. That does not follow the rules of an exponential function, and that's actually a quadratic function. So we have our base, b, which is a constant, always a number where b is greater than 0 and b cannot be 1. Okay, so that's an exponential function. Let's talk about the parent function we're going to use for exponentials. So our parent function is f of x equals 2 to the x. Okay, for this parent function, we're going to make a table. And when you go to graph all of your exponential functions this unit, you will always make a table. So let's look at some x and y values. If I plug in, let's do negative 2, negative 1, 0, 1, and 2. Let's see what that looks like. Okay, so if I plug that in, if I plug in 2 to the negative 2 power, so 2 to the negative 2. So now you got to think back to your exponent rules. Okay, let's get this right. All right, 2 to the negative 2. What that does is it actually flips this fraction, and it's really 1 over 2 squared, or it's really 1/4. Okay, so our exponential function, even though the x is negative, the y value is positive. All right, 2 to the negative 1 power, that's really 1 over 2 to the first, or just 1 over 2. Okay, 2 to the 0. What is anything to the 0 power? Anything to the 0 power is just 1. Okay, 2 to the first is 2, and 2 squared is 4. So when I go to graph this function, let's see, it's going to be hard to graph a fourth, but I'll do my best. So negative 2 and a fourth, oops, it doesn't want to do dots. Negative 2 and a fourth, negative 1 and a half. Okay, you got to do dots. 0, 1. Over 1 up 2, over 2 up 4. So now I'm going to sketch my graph through this. Okay. And looking at my sketch, notice that my exponential function will never ever cross the x-axis. For this, f of x equals 2 to the x, it's never going to cross that x-axis, although it is approaching it and it's getting really, really close. So if you'll remember from earlier this year, we have an asymptote right here at the x-axis. So the equation for our asymptote is y equals 0. So part of our answer will be that our asymptote is y equals 0. Next thing we want to find is domain and range. So the domain, that always goes with the x values. So our x values, notice that we have negative x values and we have positive x values. So in that case, we have the set of all real numbers, but we are going to use set notation, which we're not using the fancy R. Now we're doing set notation, so we need the bracket, x, close bracket. Okay, and last thing we need to find is the range. So the range of this function, we do not have any negative y values. Our y values don't start until after it crosses that asymptote. So we have all positive y values. So the way we're going to do that is set notation, all y values such that y is greater than 0. Y will never ever equal 0 because it will never ever touch that x-axis. So make sure you're using the greater than sign and not greater than or equal to, because we have that asymptote which affects our range. Okay, so let's do 2 examples. The first one we want to determine, does it show exponential growth or decay? So growth is when our function is getting bigger and bigger and bigger. So actually our parent function is an example of growth. Decay is when our function is getting smaller and smaller, or it's approaching negative infinity. Okay, so growth, we want to look at our b value. So our b value is 1.5. So our general rule for growth, the b value is greater than 1. Okay, for decay, oh no, what is that? Oh no. Okay, for decay, the b value is between 0 and 1, right? It's never less than 0, but this is when it's a fraction or a decimal. Okay, so let's look. This one is 1.5, so that means that example A is going to be growth. All right, and then we want to graph our function. So we need to create a table of values and sketch it. So our table of values, we typically want to start, we want to have values above the asymptote and below the asymptote. So I'm going to do -1, 0, and 1. So -1, 1.5 to the -1, that's just 1 over 1.5, or 2/3. Okay, anything to the 0 power is 1, and then 1.5 to the first power is 1.5, or 3/2. We'll leave it as just 1.5. Okay, so let's graph this quickly. Okay, so -1 here, 0, and 1 is at 1.5. So here's my graph. My asymptote did not shift. I still have my asymptote at y equals 0. Okay, our next one, part B, our b value is 0.8. That means it's going to be decay. Okay, so let's make a table of values so we can graph it. I'm going to use my same numbers, -1, 0, and 1. Okay, so this is just 1 over 0.8, which is the same thing as 10 over 8, which is 5 over 4. All right, and then anything to the 0 power is 1, and then here I can leave it as just 0.8 to the first power, it's just 0.8. So let me graph this. So this is decay. So notice the shape of this graph is going to be different. Okay, so at -1, I'm a little bit past 1. And at 0, it hits 1. And then at 1, it is at 0.8. So this one is actually getting smaller and smaller and smaller. Okay, so notice the shape of my graph, how it's different. Even though we have the same asymptote, y equals 0, this function is decay.